Hi, everybody. Welcome to class today. If you would take a minute to just find the area of these two parallelograms, just take a second on that. Okay, everybody, in the chat box, would you type in what is the area first for this rectangle? And yes, that's right, it's 40. And how about the parallelogram on the right? Okay, and that's right. So both of these parallelograms, the rectangle and the more general parallelogram, both have areas of 40. Now I'm going to give you one that's a little bit more complicated. And I want you to take a few minutes because there are several ways to do this question, but here's a parallelogram. The bottom left corner is at 0, 0, because it'd be easier to work with these starters like that. And the other 3 points are 9, 3, 11, 10, and 2, 7. I'm going to pause the recording, and I'm going to have you. Actually, I'll put you into breakout rooms. Let me just pause the recording. A couple people got 57 as their answer, and then there were some other answers that came up in there. In geometry, they would have shown you that one way you could find the area of this parallelogram would be to make what's called a bounding rectangle around it. And to somehow split up that rectangle into shapes, which include the parallelogram. And there are various ways to do it. For our purposes, if I make those two rectangles, I split up this picture into the, into the very large rectangle, the two small red rectangles, and then there are the two blue right triangles, which appear to be congruent to each other, and also these skinnier purple right triangles. And there are other ways to split this up, but you'll find that this way will be the most useful. So we can see here that if this point is 9, 3, this would be 3, and this would be 9. But because of like the symmetry of the picture, it's going to be 3, 9 also. And since this is 2, 7, this line segment here is going to be 2, and so is that one. This line segment is going to be 7, and so is that one. And this is 2 here, and that's 2 there. So the large rectangle is 7 plus 3 times 2 plus 9, which is 110. You want to subtract away 2 squares, which are 2 times 2 times 3, which is 12. Then you subtract away the 2 triangles, but the 2 triangles are each 1/2 base times height. There's 2 of them, so I could just put these 2 together and just get 9 times 3. And these 2 purple triangles, each is half, 2, 7, so it's minus 14. And when you do those, you should end up, what I like to do is combine the negatives first. So 12 plus 27 is 9, plus 14 is 53. So it's 110 minus 53, which is 57. But it's going to be this. If I call this point A comma B, and this point here, C, we actually don't even need to know the coordinates of that point there. But if I wanted them, someone could type in to the what are the coordinates of the top right corner point in this generic general state with the A, the B, and the C, and the D. That's right. It's A plus D plus D, because here's D. And because this line is like the same as this line here, the same slope, same distance. So 0, 0 to AB goes A to the right. This is going to be A plus C and B plus D. If I do the same dissection, looks like this: C, D, D, C. Those are the D's. And here is an A, and an A, and an A. And those are all the A's. And here's the B. The C over here is also. Okay, now what I would like you to do is, can you do the same sort of calculation now, where you work out what's the area of the large rectangle? What's the area of each of the small rectangles and each of these 4 triangles? And go ahead and you'll get a pretty ugly expression, but it's an expression that will simplify at the end. So let me pause the recording to give people time to think about that. Okay, everybody, I see Ed put in a very nice solution there. The big rectangle is C plus A times B plus D. These two smaller ones are both AD, so it's minus 2AD. And each pair of triangle, we have these two are each 1/2 AB, so it's just together, it's just AB. And these two together are just CD. But if you FOIL this out, BC plus CD plus AB plus AD minus 2AD minus AB minus CD, the CDs cancel out, the ABs cancel out, and the AD minus 2AD turns into minus AD. And we end up with BC minus AD. Where have we seen that before? Maybe if I rewrite it as minus AD minus BC, then we'll really have seen it before. Where have we seen that? Yes, the determinant. So it turns out that the area of the rectangle that has 0, 0 as one of its corners, the area is going, make that better. The area is the absolute value determinant. Yesterday, when we learned determinant, I didn't write this dead sim, the letters DET. It was just implied. But since there's an absolute value around here, I'm going to write determinant of. You write it like this: A, B, C, D. Which ends up being absolute value of AT minus BC. And I mentioned yesterday about determinants and about how it's the L factor of the areas. So if I were to take a small square, like a 1 by 1 square, and I were to run all 4 points through this transformation, that square would turn into that parallelogram, and the area of that bigger parallelogram would be the determinant times 1. And that's why this works. By the way, you could also write it this way. So these are the coordinates. So you put A, B, and C, D kind of vertically like that. You'll still get the same answer because you still get AD minus BC, regardless of whether you put the AB like next to each other or like this. So it's up to you. And that's a pretty formula for the area of a parallelogram. Now, another shape that we can find the area of is a triangle where one of the vertices is 0. 5, 4. Okay, would everyone take a minute to think about, based on what I just saw, the parallelogram formula, how could we easily find the area of this triangle now? And what do you think that area is? So take a minute on that, please. Okay, does anyone have any thought about how knowing the area of a parallelogram can help you find the area of a triangle? I see 12.5, I see 10, 3. Oh, good. I do see 12.5 as the answer. A side length 0. And I see from Chelsea 12.5 with a determinant because, and that's right. The thing to realize about this question for a triangle is that even though it's not a parallelogram, a parallelogram could always be split into 2 congruent triangles. And even though we aren't told this point here, it doesn't matter because the area of the parallelogram was it was the whole parallelogram. It would be the determinant 5, 4, 10, 3. I'm going to put that for, I'll write determinant, but then I'll stick absolute value around there. We have to divide that by 2 because it's a triangle. So now we have formula for the area of a triangle. In this case, it's 1/2 absolute value of 5 times 3 minus 10 times 4. 1/2 15 minus 40. 1/2 of is 12.5. It's a pretty good formula. I'll write down area equals 1. If this point was called AB and this point was called C comma D, then the area is 1/2 absolute value of the determinant of A, B, C, D. So those are the 2 main formulas for today's lesson. And they really go back to what the definition of determinant is. And if I'm able to, I have a YouTube video that's really good. There's a YouTube channel called Brown, One Blue. I think it's called that. Does anyone know? Is that what it's called? 2 brown, 1 blue, 2 blue, 1 brown, 3 blue, 1 brown. I think the guy who makes it has a blue eye, and his other eye is half blue, half brown. So 3/4 of his eyes are blue, and 1/4 of them are brown. I think that's the story with him. Anyway, he made a really nice video, which I'm going to either show you or I'll just send you a link to watch that. Well, this is good if the one of the points is 0, 0. What if one of the points is not 0, 0? So here I have like 3, 4, 12, 5, 6, 9, and 15, 10. Okay, so we've got a bunch of other stuff going on here. And I see from Talia, the easiest way to do this question is to translate and then use the 2x2 determinant. Okay, so take a minute on that. Okay, someone please tell me what are the coordinates of the top left and the bottom right now? That's right. 3, 5, and 9, 1. We've went left 3 and down 4 from each of these. We don't need this point here. We take the absolute value of, well, why don't I just write down 3, 5, 9, 1. I'll stick an absolute value around there also. Kind of have to write the word dead, otherwise it gets a little confusing. So 3 times 1 is 3. 9 times 5 is 45. Minus 45 is negative 42. Absolute value of negative 42 is positive 42. And that's the easiest way, in my opinion. Now for a triangle, we can do the same thing, but I do want to show you another way. It's not even as good, but I'm going to show it to you anyway. So here's a triangle that has 1, negative 3. And over here, it's got 7, 1. And here, it's got 6, comma, negative 5. Now you could translate any of the points to 0, 0 that you want. This process will work. But if it looks like this, I'll take the point that's like furthest, the point that has the lowest x coordinate. That's the one I like. So first do this like the obvious way, shifting it, and then I'm going to show you another way, just so you just see how things sort of relate. So everyone work this one out by doing the shifting. Okay, you could type in what you got for the area using, when you translated everything over, 1 to the left, 3 up. Anyone have that area handy? 1 to the left, 3 up, 1. Okay, I see 11. Is that right? What are these our points? 0, 0, 6, 4, and 5, -2. See that? So 6, 4, 5, -2 is -12, -20. Looks like -32 was the determinant. So the answer, type it in then. So the answer is 16 is the area of this triangle. So now we have a way. Now I do want to show you, although this method is not, this other method is never, it's not a method you're ever going to really want to use, but I did want to show you that sometimes in this type of math, for whatever reason, we want to work with it without, without the translation. And at least I want to show you that this gets us the same answer, 6, -5. We would also get this answer if we did this. If we took the 3 points and all 3 points now, and it's not becoming a 2 by 2 matrix. Well, it's looking like a 3 by 2 matrix. If you were to throw an extra row, an extra column of ones. Now, this linear algebra is very sophisticated, and it's actually a full semester college course that we're like doing the greatest hits of in weeks. So there's a lot more to it than just, oh wow, why would I do this like more difficult method? But yes, if you expand this along the third column, sorry, you would get 7, 1, 6 minus 5, minus 1 minus 3, 6 negative 5, plus 1 minus 3, 7, 1. Not that you would want to do it this way. It's really easy to translate and get the answer, but this would also get us the 32, which we would then take half of to get the 16. Again, I would never actually do it that way, but I did want to show you that it actually could be done with a 3 without any translation. Somehow sticking that 1, 1, 1 enables us to perform the translation also. So I just thought that was interesting. Okay, I'm going to try to end the lesson today with the video. I'm going to pause the recording.